Hey everyone. So in this video today we are talk about that how to create images using stable diffusion in Python. So we can create unlimited images with the free of cost. Let's see deep dive into that. Before that, if you are new to this channel, please subscribe my channel. Okay, the first thing I can open the Google Collab. So in that I have an already have a script called it stable diffusion.python file. So in that Python file, which I taken from the stability.ai website, so I added in the description below for the script actually. So once you open the script, you can take a copy and you can move it to your Google Drive. So after that, you can open that your copy of stable diffusion Python script. After that, you can start that image generation in unlimited times and with the free of cost. Okay, so then make sure you need to connect with your host machine in that collab. So I just now connected, and so after that you need to make sure your GPU in the runtime in this notebook actually. So we need to run that nvidia -smi. So this command will return that if your notebook is connected with the GPU or not. So you can see that GPU fan and all the things there actually. So CUDA version 12.0. So all those things fine. And after that we need to install that necessary dependencies on that actually. So I can just install the pip install diffuser and the transformers, scipy, ftfy, accelerate. So these are the some necessary image generation related libraries I can install it actually. So accelerate is used for achieve much faster loading. That's why. So it will connect to that internal GPU things. So let it run. Now that installation was completed. So in that, so this is already I installed in my collab notebook, so that's why it shows requirement already satisfied. So you can install it, and after that we can go to the next part that called defining that stable diffusion pipeline. So currently stable diffusion have a multiple versions in that. So I can take that stable diffusion version 1.4 version because 1.5 also there, but looks like 1.4 it's more stable than 1.5. So in that I can take that 1.4 versions, and after that I can use the torch, import torch and a diffuser. So in that it will become to the stable diffusion pipeline. So in that I can already downloaded that stable diffusion dot 1.4 and torch type float 16 like that. So this is the thing pipeline we defined that. So after that so this is some only thing. So after that you can just call the pipe, and in that pipe you can pass that prompt inside that actually. So let me run, and so based on the model choice, so the model will be downloaded and it will be configured in that config.json actually. So after that I need to connect with this pipeline to this GPU actually. So all the transaction has been needs to done in the GPU side. So I can simply run that pipe.to CUDA. So so after that we can generate that simple inference image actually. So I can type Gondalf from the Lord of Rings and a diffuse lightning fantasy and highly detailed lifelike photorealistic digital painting art station like that. So I can put, and I just create a prompt, and inside that prompt I can pass into that pipeline pipe class. So the pipe class can return that image actually. So it will return that multiple images. So I can take that first image, and after that I can just save. It's some ready-made things, so I can keep it as the same. So any name you can take that actually. So image.save. After that I can run it, and let's see. Now image is downloading. Here is the thing, image is created. So based on that Gondal from the Lord of Rings, diffuse lightning, based on that highly detailed photorealistic looks like digital painting art station like that. So in that part let me add some more improvements in that image actually. So in that part in the script already they gave that tar generator CUDA manual seed. So in that I can pass the pipeline same prompt along with that this generator. So this generator will uh, add some more improvements, that means the same seed, the same image result like that actually. So I can run that. Let's see. Yeah, so in that, if you want a deterministic output in the detailed thing, so you can pass that seed values actually in that pipeline. So this is crazy, right? So you can generate ultimate image, unlimited images that's free of cost. If you take Mid Journey or Leonardo, so they have some limits there, but in that collab you can create n number of images based on that your prompt. And that next part, so I can same as, so in that generate that I can pass the seed. Along with that, number of inference step I can pass actually. So you can change the number of inference using that this keyword parameter num inference steps actually. In general, results are better in latest model with that small number of sets, right? So defaultly it's 15. So if we changed that, it will be like more detail it will becomes actually. So I can run that. Yeah, so now I can reduce that number of inference steps, so it looks like image gets too softy actually. So before the images it's crisp looks like, but if I reduce that number of inference steps, it will be reducing that crisp, and it will be gets more soft actually. So I'll go to the next part, and so in that part I will make a grid function. So so this grid function I used for to display the multiple images in that web page actually. So I can just run that function, and let's see. So once this function is runs, after that I can run that same command Gandalf from Lord of Rings. And so before the previous cell I can choose that first image, right? So I can now I can result the three image actually, so in that row. So that's why I created that image grid. If I run that, now that three images is downloading. So row 1, column 2. So the three images just print over there. If you put more rows, so multiple images also will come based on that actually. Here is the thing. So now three images were generated over there. And the next part, we can see that how to grid of nm like that. That means three rows and four columns. I'm already said, right? So in that same input, with I can pass that prompt, same prompt with the multiple times, get all the images and show it in the grid level. Let me run it. Yeah, now image is generated. That means the number of four rows and the three columns. So in that, if you see that, yeah, so it looks like very realistic, along with the, some of the mistakes there, but anyway that is good. The next part, Stable Diffusion produce the images of 512 into 512 pixels by default, but it's very easy to override default using the height and width arguments. You can create the rectangular images in that portrait or landscape ratios. So in that same as in that pipeline method, so you can pass that your prompt along with that height and width, so it will be returning that specific size of images as you want. So let me run it. Yeah, so here is the output. So it will be returning that 512 into 512 ratio of size image actually. So I can show you how create a custom diffusion pipeline with the diffusers. So in that it's very useful to dig a bit deeper into it, certain functionalities of the system. So let's get started. So in that I can use that same as torch along with the torch device. If it is CUDA is available, I can take CUDA, or else I can take a CPU. Yeah, I run that. And after that, we can choose that pre-trained model of that. So in that pre-trained model, so I can choose as the same 1 point stable diffusion 1.4 along with that BERT actually, such as encoder actually. So tokenization, it's used for the text encoder model and the scheduler and unit and VAE. So unit and VAE used for that latent representation of input along with that decode latent representation of real image. So In that part, in the transformer library, I can import that clip text model and a clip tokenizer. And the diffuser level, I can import the three major things, and auto encoder KL and a unit and a DMS scheduler actually. So after that, in that, so stable diffusion, as a VAE, that mean I need a real images actually. And the tokenization I can use it for that. OpenAI have a multiple encoding thing is there. So in that I can take that clip VAT large and the clip VAT large patch 14 for that both tokenizer and text model on that actually. So the next part, unit model. So unit model is that we already imported that from the diffuser. So in that unit model 2D condition from the pre-trained as a stable diffusion subnet unit. So now we have a VAE and a tokenization and a text encoder and a UNAT. So in that, let if I run that, it will be first it will be downloading that necessary models and necessary encoding weights actually it will be download. After that we can go to that next parts. Let it wait. It's downloading. Yeah, now it's completed. Instead of loading predefined scheduler, we'll be using that KLMS scheduler instead actually, because there is a lot of predefined schedulers there. So that's why I can use that LMS scheduler instead. So LMS scheduler also comes from the diffuser library. So I can simply pass that LMP create scheduler from pre-trained model of stable diffusion with a subfolder of scheduler. So it's very easy, right? So what you need to do is, so you need to understand that code flow, and you can just tweak that some of the parameters. That's all. I can move the next part. I can move that models to the GPU. So in that, all the things under the torch device. So torch device is a GPU. We already from that initial level, we get it right. Torch device. If CUDA is available, it will take CUDA, or else it will be take the CPU. So in that, Google Collab already give that free of GPUs. So I can use that VAU torch device. So and a text encoder to torch device, unit to torch device. I can move to all the things to the GPU. And after that, we need to define the parameters we'll be using to generate the images as well. So in that part, I can put the prompt same as Gondal from the Lord of Rings, device of lightning, etc., etc. So in that I can define that necessary library, so necessary configuration, right? Height, width, number of inference step, guidance scale, generator, and batch size actually. So if I run that, after the running, the configuration will be configured in that memory. So we need to get the text embedding from the prompt. These embeddings used with that unit model actually. So I can call the tokenizer class, and in that prompt, along with that prompt and the padding and maximum length, that means the model max length, and truncation true, and returning tensors pt. So in that, with no grade is there, so at the time text embedding will be analyzing the text, and it will be returning that first thing actually. Let me run. So after that, we have a text unconditional text embedding for the classifier free guidance, right? So which are these embeddings? It will be using for that to make a shape for the conditional text embedding. So I can run that. So in that, same as we have a text input already there from that 38th cell, and it will be getting that, it will be returning that unconditional embedding to a conditional embedding actually. So after that, we need to uh, catting that function actually. So let me run. And after that, we need to generate that initial random noise for that model, along with that shape. Okay, cool. So shape is now 64 into 64 expected, and the model will transform this latest representation, the pure noise, 512 into 512 image later on. That we can utilize that scheduler, our chosen of inference steps. This will compute that sigma's exact time step out that during that diagnosis process. So let me set the timestamps to the inference steps actually. Now set it. After that, I need to multiply with the sigma values with the lanterns actually. Yeah, so we are almost done. We're ready to denoising loop. So in that tqdm along with that torch autocast, so in that we are already have a model with the tokenizer or text model already we have. So we can just run that script, and in that it will be creating that 5 toll into 5 toll pure noise image things actually. Let it run. It's loading. Yeah, now it's loaded. So now we use that VAE to decode that latents and back to this image. So it's a simple thing. Latents 1 by divided from 0 1 8 with along with that latents. I can just scaling that, and let it show. And finally, let's convert that image to pill, and we can display and save it actually. So simple thing. I can just execute it, and let it wait. Yeah, now it's completed. Yeah, so here is the final image. Now we have a decent pipeline piece of. We hope you found this video informative and helpful. If you did, please hit the like button and consider to subscribe our channel for more videos like this in the future. Also, don't forget to share this video with your friends and colleagues who might find it useful. If you have any questions or comments, please leave them in the comment section below, and we'll be happy to respond. Thank you for watching. We'll see you on the next video.